So due to high noise, always in the receiver will have an LNA. The antenna will pick all possible noise. So if you have a strong LNA, your LNA will filter out all the noise. So this omega in minus omega LO is called as the intermediate frequency IF. And it is very, very important that this frequency plays a crucial role. And heterodyne, the name we are seeing heterodyne receiver, heterodyne means omega IN and omega LO frequencies are not same. Omega IN not equal to omega LO. If omega IN equal to omega LO, then IF will be equal to 0. So when you are going to use a non-zero IF, we are going to use heterodyne receivers. So how does a heterodyne receiver cover a given frequency band? We have two options. First, the LO frequency is constant. Each RF channel is down converted. So whatever RF channels you have, everything will be down converted to the corresponding IF first. So RF1, RF2. See here, if I have first case, RF1 I mix with FLO, I get FIF1. RF2 I mix with FLO, I get FIF2. RF1 I mix with FLO1, I get FIF. RF2, if I mix with FLO2, I get FIF. See, in these two things, two different things. RF frequency is changing, LO is constant, IF frequency is changing. The second case, RF frequency is changing, LO is changing, IF is constant. So two possible configurations are available. So since that is what is explained here. So we don't use the first thing, we use the second thing. We try to have a common IF. We vary the different value of LOs and we try to have a common IF because that will help me in designing a common filter. Okay, so when the IF frequency is same, it will be easy for me to tune the particular filter to get back the frequency. But in previous case where IF frequency is different, so I need to have different filters. So second case, in IF same frequency is there, the single filter will be sufficient. So this approach demands a frequency loop and what is called a synthesizer. Because you see, my LO frequency is changing. So I need to generate different LOs. That is okay. I can do that because my filter complexity is getting reduced. So I'm happy here that at last I have solution for channel filtering. I say that at the receiver to generate the same IF, I use the same filter here and same filter here, but I need to have different values of LOs, which is generated by a device called as frequency synthesizer. So that is the basics of your transceiver architecture.